And next we're going to look at the codon wheel activity. It's under week 11, day 44, codon wheel activity. It says determination of proteins and amino acids from the mRNA's codon chart. So amino acids in the codon wheel. This is the wheel. We looked at a chart earlier. This is a wheel, and it's, some people think it's a bit easier to use than the chart. So the wheel at the right shows you how to determine which amino acid goes with which mRNA codon sequence. So to decode a codon, start at the middle of the circle and move out. Okay, for example, AAC. Let's start at the middle at A, and the next one's A. So it will be this little section, and then C is right there. So AAC would be asparaginine. Okay. So we can put that there. AAC would be asparaginine. Okay. Next one's UCU. Okay, start in the middle. U, second letter C, and then U's right there. So serine would be next. GAU. Start at G, go to A, and then go to U. And it'll be aspartic acid. G to A to U, aspartic acid. And then CCC, start right there, C to C to C, it'll be proline. Pretty easy to use there. Number 2 said, what would the codon sequence be for leucine? So let's find leucine. Here's leucine. And sometimes they'll be in more than one place. So there it is again right there. So what the codon sequences be for leucine? So we're going to start right here. It would be C, U, and here it could be C, U, U, C, A, or G. They're all going to start with C and U, so C, U, A would be one. C, U, C could be one. It's coming from right there. C, U, C. C, U, A we just said, and then C, U, G, and C, U, U. And it also has some leucine up here. And up here it would be U, U, A, and U, U, G. And then for valine is the next one. Okay. So we're going to find valine. And valine would be right there. There's valine. So they're all going to start with G, and then U, and then it could be G, U, G, G, U, A, G, U, C, or G, U, U. Fill those in. And it says, what are the mRNA stop codons? Well, we said earlier the AUG was a start codon. So we have AUG methionine that tells ribosome to start making a protein. This one wants to know what tells it to stop making the protein. So stop is right here and right here. So there's a couple of different ones. This would be UAA or UAG. And then right here we have UGA. So UAA, UAG, and UGA. Those are our stop codons. Tells that ribosome you're finished. We stop right there. And what amino acid sequence would be made from this mRNA right here? Let's slide it up a little bit so you can see. Okay, so we have CGC, which would be one codon. Then we have UAU, which would be a codon. And then AGC, that would be a codon. So CGC, let's see what CGC is going to be. So C to G to C. That's going to be arginine. I'm just going to put ARG because it's not going to fit if we put it off. And it's going to have a peptide bond to that next one. So the next one would be UAU. So find U, go to A, go to U. That's tyrosine, TYR. And then next we have AGC. So go to A, go to G, go to C, and that's serine. And CR. And those amino acids are held together by peptide bonds. Get a bunch of them together, it makes a polypeptide. So that's the wheel. Some people think the wheel is easier to use. Some people still prefer the table down here. So part 2, amino acids in the codon chart. So the chart at the right shows you how to determine the amino acids going from the mRNA codon to the amino acids. And we talked about that earlier, that you're going to go from the first letter on this side, second letter on that side, and that'll narrow it down to one of the boxes. And then this third one will help you go to the specific one in the box. So to begin with, we have GUA. So find our first letter is G, so we're going to be in here. U is our second letter, so that narrows it down to just this box right here. And they're all valine, but for our third one, it will be A comes straight across, so it will be this specific one right here. So G to U to A comes right there, valine. Then we have UUU, so find our U on the first side. There's a U right there, so we're going to be inside this box. And there's some couple of choices there. So we have to get the third U comes straight across right there. And it's going to be phenylalanine, so PHE. Then we have CAC. First letter, C. Second letter is A, and they meet right here. So that will be our box. C coming across, A coming down. We're going to be somewhere in this box right here. Our next letter is C. So C across right there, and it'll be histidine, HIS. And then we have UAA. So we go to U. It's going to be somewhere in this row. A is going to be this column, so where they meet right here in this box. And A, there, so it's a stop codon. And number 2 says, suppose the DNA sequence GCTATATCG was changed to GCCGATATCG. And how would that change what we have? Well, we have GCT and GCG, so it's going to be a little different. And we'll look at it. Let's take it a codon at a time. And so this is our DNA. We've got to go to our mRNA. For this one, so G would go to C, C would go to G, T would go to A would go to U, T would go to A would go to U, T would go to A, C would go to G, and G would go to C. And Those amino acids would be CGA, go to C, G to A, so arginine would be our first. ARG. It's a pirate's favorite amino acid. And then we have UAU. U to A to U. That's going to be tyrosine. T-Y-R. And then we have AGC. So A to G to C. That's going to be serine. So that first DNA sequence would eventually code for arginine to tyrosine to serine. So let's look at the second one. We had a little bit of a mutation. GCG. It was a T, now it's a G right here. So let's see if that changes anything. Let's do our mRNA. And G would go to C. C would go to G. G would go to C. A would go to U. T would go to A. A would go to U. T would go to A. C would go to G. And G would go to C. Okay. Oops, not a Y. Supposed to be U. Okay, so let's see how that compares. So this codon right here, we had CGA initially. Now I have a CGC. The UAU codon is still the same. AGC is still the same. Let's see what changed with our CGC. So go to C, over to G, and go to C. And that would be arginine. So it's still arginine. ARG. And the next one's the same. So it's TYR. And the next one's SER. So in this case, even though we had a mutation in our DNA, we had a base change. We had a substitution there. One came out, a different one went in. Even though we had a substitution in our DNA, and it made our mRNA a little different, that codon still matched up with the same amino acid the original one did. So that mutation doesn't cause an issue. It did not change the protein. Sometimes you'll have a mutation, a base change, maybe that a substitution that made it pick up a different amino acid. Or sometimes a whole section may be missing. There may be a whole 2 or 3 amino acids that are just not there at all. And that would change the shape of the protein, which would change its functionality. It may not be able to work at all. Or it may even totally prevent a protein from being made if there's a mutation. For example, if we had changed, if our DNA, if that G had been substituted with a T, then we would have had an A right here, and that could have been TG, that would have been an AGC, so AGC would have been serine. So that would put a serine right here, and that would have been a totally different amino acid sequence, and that could have totally changed the functioning of that protein. So those amino acids, those base sequences, those bases in the DNA, can change the mRNA, and they can change the amino acids that will be picked up, which would totally change the protein, sometimes preventing it from being made at all, especially if you end up with a stop codon being somewhere it shouldn't have been, or if you end up not having that start codon at all because of a mutation. It can totally prevent the proteins from being made. And sometimes you luck out. Sometimes the mutation is just one little change, and it still codes for the same amino acid. Because notice, most of them have several different ways of making it. Methionine, of course, that's our start codon, our start amino acid, and it's the only one. I mean, it only has one way of making it. So it's just AUG is going to be the only way to get the methionine. So if something happens to that AUG, and you end up with something besides AUG there, then that's not even going to start making that protein. Or sometimes it might change just one amino acid, and that just makes it bend a little different, which it might still work, just not as good, or it might make it bend in such a way that it doesn't work at all. Okay, so that's how you use the codon wheel and the codon table. And we'll practice a little bit more with those later.